Ladies and gentlemen, it's no secret that a great city always has a look and feel of its own, and it's no accident it takes an eye and a vision for design. And that design is being influenced by the data that was such a feature in the last panel, indeed earlier today. This is particularly true now, where many cities are seeing record growth and also opportunities to remake themselves and to be more resilient and sustainable in this age of urbanization. One of the true visionaries in this field is our next speaker. Would you please welcome Jay Mezher with Parsons Brinckerhoff. Thank you for coming.
Thank you. So I'll be talking today about some of the digital tools that influence the future of our cities. I work for an infrastructure company, an engineering and architecture firm, Parsons Brinckerhoff, and we focus a lot on the emerging technologies to design and construct projects. So building information modeling is a new technology that has changed how projects get designed. Instead of designing using 2D drawings, you're designing a job right now using a 3D model. And what that allows you to do is combine several 3D models together. You laser scan existing conditions, you build your structures and facilities models, roads, rail, and land development. And then what you do next is integrate your model into one data set. Now you're going to ask, why do I need to do that? Because what this integrated model allows you to do is generate construction drawings, use it for visualization, public outreach, and communications, stakeholder management. And then more importantly, you'll be able to take quantity takeoff, do constructions logistics planning, validate your design before building it, and then you can add cost attributes, do constructability reviews, and we're seeing a lot of clients are asking for those BIM models or 3D models so they can use them for operation and maintenance. Now, I'd like to talk about an example. I worked on the Alaskan Way Viaduct and seawall replacement project for 8 years. The existing viaduct was damaged after the 2001 Nisqually earthquake, and WashDOT embarked on a process to redesign the project. So from 2002 till 2006, they looked at how the project might be redesigned, and at the time, we started working on the job as a GEC, General Engineering Contractor, but our group was building a 3D model basically to show what the design looked like. You've seen a lot of these simulations. This is my project. That's how it's going to look like. But because we used a 3D based approach rather than an illustration, the model that we have started evolving. And by 2006, when those two options were voted down, WashDOT went back and looked at more than 90 different options to redesign the waterfront. It was a challenge. How do you display these options? And then it was all narrowed down to 8 different options. So we leveraged the model that we have into those simulations and put them in an app that you can look at 8 different options and then compare between one option and the other. This was used for public outreach. It was used for the stakeholders to help them make a better decision. Another application of the same tool was looking at the South End detour. So with a quick slicing of the model, you can generate construction phasing and then package it, put it in an app that's accessible by anyone. Now, by 2009, when the decision was made to build a deep bore tunnel, we had developed the entire city in 3D. So right now, we have the whole Puget Sound area built in 3D. And this is an example of how this model was used on the project to show what the new design is going to look like. The model was built from accurate GIS data. It leveraged the exact same footprints, but more importantly, we were able to map all the underground utilities and place different alternatives under the city and help the designers and the project team pick the best option for the job. So again, having a tool like this enabled us to answer any question that they have. They wanted to know the depth of the crown. They wanted to look at constructability. This is an example of a dashboard that we put together that shows light and shadow studies, which is really important for the environmental process. When you look at 8 different options, these things get into play. You're looking also at demand for excavation, concrete, labor. You're looking at the constructability review of the Deepport Tunnel and then the South End construction sequence. So again, this database that started with a simple simulation started growing into more of an information data set that you can access any piece of information that you want. Now, another interesting application of the, sorry, I apologize. Let me see. This video is not running. There. So here's another interesting application of the data set that we have. In 2008, we were asked to simulate the collapse of the existing viaduct. So it's basically the same earthquake as in Nisqually, except it would have had it lasted 20 seconds more. We based the design, we based the simulation on the Corps of Engineers seismic report, and we worked with the engineers to figure out exactly how this viaduct would collapse. What you're seeing right now is, again, the same data set, the same 3D digital model of the city, except we overlaid the lights because we wanted to highlight that power, that they would lose power in the event of an earthquake. And so that's the Alaskan Way Viaduct. That's the existing structure, initial shock wave. So soil liquefaction starts, and then it compromises the seawall. So once the seawall fails, then it compromises the foundations of the viaduct. Power goes off. And then this is one thing to note is that this is accurate. This is data driven, and it's feeding from the engineering data. All the cars, all the other data sets and props are linked to it. So when it falls, it's physically accurate how everything else collapses. When we zoom out, we're looking at different failing mechanisms. This was something that was coordinated with bridge engineers and seismic experts from the University of Washington. So there's pancaking, plunging, and other failing mechanisms. Again, it's a different use of the same data set. We looked at using it for design, for validation, light shadow analysis, constructability, disaster planning, floodplain simulations is also something that can be leveraged using those data sets. So the fair lights are still on. So we looked at the factors that shape urban growth from a transportation standpoint. There are other things that affect urban growth: land use, zoning, sustainability, infrastructure, energy, resiliency. Once we had this model built, we started realizing that we have so much information into it. It's a living document. Every time we have a new job, we input more into it. So now we have existing tunnels that are underground. We have the proposed tunnel. We have the utilities, the seawall. We have all the terrain. We have all the buildings. And then we're adding energy metrics to it. We're adding land use. We're adding all those attributes. So you end up with basically a virtual city that you could use for visualization. You could use to communicate design concepts. You can pick any view, above ground, underground. And then you can also overlay traffic simulations on. A very important issue in any city. vSim, traffic simulation software, can simulate now any option. They can look at different alternatives. They can validate what the new intersection is going to look like, how a new development is going to impact a certain road or highway. But now you can overlay all this information into the same data set that you have. Again, another use of the model was looking at land use. This is not a photo, it's a rendering. And then we're looking at existing zoning, looking at a possible suggested zoning. Hundreds of design ideas come up, and you could quickly look at how it's gonna be in the city. View corridor studies. Pick any picture that you want, any view in the city, and simulate what a development's going to look like, what another proposed development's going to look like. Because it's georeferenced and because it's accurate, you can simulate lighting conditions. Light shadow analysis is really important for the environmental process. You can look at any structure in the city, any area, and then simulate lighting at any time of day. And it's all intelligent. It could calculate how much shadow there is, and then it could look for differences and compare scenarios. So that's the existing city. You can validate it with proposed developments, with other options, pretty much anything that you want. It's a virtual world. Now, another interesting thing that we discovered along the way was if you tag attribute information to the model, you could run a quick simulation. So we went back to the city archives and online and found every single building when it was built and tagged this information. So now I can show you any year, any given year, what the skyline looked like. So we started with 1960. Again, a lot of it is just information that is available online. A lot of cities, like it was mentioned before, are putting all these data sets online. It's just a question of integrating them and then linking them to the proper data sets. And how do you use it? So look for the kingdom on the right before building the new Seahawks Stadium. Again, that was a simple exercise just to show the city skyline, how it evolved. This is another interesting application of the same data set. We're seeing a lot of interest right now in carbon emissions and greenhouse gas emissions. This is a project this is a Tyson's Corner project. It's a transit-oriented development, and they looked at multiple scenarios, and we baselined the existing scenario, and then looked at in 5-year increments what is the carbon emission per capita, and also separated it. What is the carbon emission from auto trips, from building use, by residential, office, etc. And what we did is we used gaming technology to link to the geospatial and design data sets and created this application where you can look at it in real time. Go to any time that you want, any year, look at different scenarios. Hovering over the bars would give you exactly what the numbers are. Again, it's a new way of sharing information and then helping everybody get on the same page before they make a decision. Another example of carbon emission modeling is this tool that we developed for the Urban Land Institute. This was part of a reality check exercise that was done in Seattle with the major stakeholders in the Puget Sound region. So they gave everyone Legos and they said, we want you to think how this region might grow best. Is it dispersed, medium, compact, or compact? And those are the scenarios that came out of this exercise. We again leveraged the same framework of using this virtual modeling tool, and we looked at modeling those carbon emissions. We listed the business as usual reductions and then state reduction targets. So this is an executable file. You can take it on a thumb drive, put it online. But what you can do is just you can navigate in real time and look at all these results. So rather than reading reports and taking the time to look at documents, this real-time application gives you all the information in one data set. And then this is where we see things are going. So this is a tool that not only shows 3D information with attribute data on buildings and design information, it also shows the time, which is the fourth dimension, but more importantly, all the attribute information that is in the model is displayed on this application. So at any given point in time, you can look at any metric that you want. In this case, it was employment, sewage, water, gas, electricity, traffic. So we think this is a great tool to help project design, and it's going to impact the way cities are going to be designed and the way they evolve. So the more information you put into these data sets, the more you can get out of it. It's a different mindset, it's a different framework, but once you start thinking what you can do with these models, the options are endless. And then I'd like to end it on this quote from Canadian futurist Marshall McLuhan. "We shape our tools and they in turn shape us." We had no idea this was going to happen. In 2002, even before that, we started with simple simulations, 3D models to show what a project looked like. Now it's evolving into design validation, linking it to schedules to validate what the construction is going to be like, linking it to cost to find out what is it going to cost. And with new technologies, you'll be able to simulate hundreds of options rather than one option. It's certainly going to impact the way projects are designed and how cities evolve. So thank you.